Hello friends, I am Rajaneesh Chandran. Welcome back to my YouTube channel. Here we are going to study about engineering graphics. So in the previous video we have discussed about rotating line method. We have learned the concept of rotating line method, and we have also solved around 5 problems or 5 different type problems in rotating line method. So I have already told for the projection of lines there two methods are utilizing. One is known as rotating line method and the second one is known as rotating plane method or trapezoidal method. So in this particular video we are going to study about a rotating plane method or trapezoidal rule with the help of an example. So I will give you the concept while solving that particular problem. The distance between the projectors of a line is 40 mm. The point A is 10 mm above HP and 20 mm in front of VP. The point B is 40 mm above HP and 55 mm in front of VP. Draw the projections, obtain the true length, true inclination and locate the traces. So the problem is the distance between the projectors of a line AB is 40 mm. That means, see the distance between the projectors of A, so it is given as 40. So the distance between the projectors of A and B is given as 40 mm. Point A is 10 mm above HP and 20 mm in front of VP. Point B is 40 mm above HP and 55 mm in front of VP. So obtain the true length of the line AB and the true inclination and locate the traces. We can start with the XY line. So draw the XY line. See, whenever the distance between the two projectors and the location of both the endpoints are given, we can completely draw the projections A dash, B dash and AB. And once you completely draw or once you have the projections A dash, B dash and AB, then the best and easy method for completing the projection of lines or obtaining the true length and true inclination is rotating plane method. Actually, this rotating plane method is easier than rotating line method. Concept-wise, it is a little bit difficult, but the procedure for rotating plane method is very easy compared to rotating line method. So here you can see that the point A is 10 above, 20 in front of. So point A is 10 above and 20 in front of. So we can name this as A dash and this as A. Now at a distance of 40, see point B is given as 55 above and 40 in front of. So the point B is given as 40 above and 55 in front of. And the distance between the projectors of A and B is given as 40. So this is a projector through A. So at a distance of 40 mm, there will be another projector and that projector will contain the endpoints B. So at a distance of 40 mm, we have to draw another projector, that will be the projector through B. Which means this will be the projector through point B. On that line, we have to mark B dash and B. B dash is given as at a height of 40. So at the height of 40, we can mark B dash. So B dash is being marked. Then in front of 55 in front of. So this is. Now you can see that A dash B dash is available as well as A dash. So we have completed the projection A dash B dash and A. That I have already told. Once you have both the projections A dash, B dash and AB, the best method for completing the projections is trapezoidal method. Now I will explain what is actually trapezoidal method is. I will give you the concept in a later stage. Now I will provide you the working method of this trapezoidal method. See, this is XY line, this is A. Take the distance between XY and A. Take the distance between XY and A. This is the distance between XY and A. Draw a perpendicular through A dash and mark that distance on that perpendicular. That point will be our true length point A1. See, the rule is take this much distance. That means the distance between xy and A from A dash, draw a perpendicular through A dash B dash, and on that perpendicular measure this value and mark, name that point as A1. That will be the true length of that point will contain the true length of A dash AB. So that will be the starting point of the true length AB. Similarly, select the distance between xy and B, that is this distance. Draw a perpendicular through B to A dash B dash. Draw a perpendicular to A dash B dash at B dash. Take this much distance. So we have obtained a point here. Name that point as B1 because it will be the second end point of the true length. Connect these two points. So this will be the true length of this projection. Why I have marked it as A1 B1 means it is the true length that we have obtained. It is the first true length that we have obtained while solving this problem. So the method is take the distance between xy and A, mark it on the perpendicular through A dash. Take the distance between xy and B, mark the distance on the perpendicular through B dash. Now, take the distance between xy and A dash. Take the distance between xy and A dash, mark the perpendicular here. This distance can be marked either in this direction or in this direction. This can be marked either in this direction or in this direction. So, I have taken this value and I have marked it here. So, this will be our another true length. So, it is marked as A2. Similarly, take the distance between xy and B dash. Draw a perpendicular through B and mark it on. That will be. So actually, this is 1. This distance can be named as 1. So this also has to be marked as 1. This distance is 2. So this distance is also marked as 2 for identifying and tested. What is the distance? What are these distances? Now this is 3. So this also will be 3. This is 4. So this also will be 4. So this is our second. So we have obtained both the true lengths A1 B1 and A2 B2. If you are doing the problem in correct manner, this A1 B1 and A2 B2 will be same. So for obtaining the true length, take the distance between xy and A, mark the distance in a perpendicular through A dash. Take the distance between xy and B, mark the distance from B dash. Take the distance between xy and A dash, mark the distance from A. Take the distance between xy and B dash, mark the distance from B. So that we have obtained the true length. This A1 B1 means it is the first true length that we have obtained. A2 B2 is the second true length. A1 B1 and A2 B2 will be equal. So now we have obtained the true length using rotating plane method or trapezoidal method. Now we have to calculate or we have to measure the true inclinations of the line with respect to HP and VP. So in trapezoidal method, the rule is the angle between this AB and the corresponding true length. AB means the top view. So the angle between the top view and the corresponding true length will be theta. The angle between AB and the corresponding true length will be theta, which means for calculating the angle, extend this line, extend AB, you can extend A to B2 also, extend A to B2, so that we have obtained an intersection point. So this angle will be equal to theta. So the angle between the top view AB and the corresponding true length will be equal to theta. And the angle between A dash B dash and the corresponding true length. This is A dash B dash, extend A dash B dash. extend the corresponding fluid. So this angle will be equal to phi. You can measure the phi. This angle will be equal to phi. So in trapezoidal method, for calculating the true inclinations or measuring the true inclinations, the angle between AB and A2B2, angle between AB and the corresponding true length will be theta, and the angle between A dash B dash and the corresponding true length will be equal to phi. So we have calculated or we have measured the true inclination. That means we have calculated the true inclinations of theta and phi also. Now we are moving to a new term which is known as a trace. So what actually a trace is? See, assume this is horizontal plane and this is vertical plane and this is a line. This line is now inclined with both the VP as well as the HP. See, assume this line is extended towards one of the reference plane. This line can be extended towards VP as well as towards HP. So when this line is extended to HP at a particular point, this line touches the horizontal plane. Clear? This line, while extending at a particular point, it will touch the horizontal plane. Similarly, if we are extending like this, it will touch the vertical plane also. So the point where this line touches the reference planes are called traces of that line. When this line is touching, the point where it touches the horizontal plane is known as horizontal trace and the vertical plane is called vertical trace. So what actually a trace is? See, this is a line. On extending that line, it touches the horizontal plane at a point, and that point is known as a horizontal trace. So what actually horizontal trace? Horizontal trace is a point. Where that point is situated? Horizontal trace is a point on HP. Horizontal trace is a point on HP. We have learned how to mark the projection of points. So now we know that the horizontal trace, usually horizontal trace is indicated as HT. So this horizontal trace HT is a point on HP. We know that every point will have two projections, A dash and A. If the point is A, the projections will be small a dash and small a. And if the point is capital HT, its corresponding projections will be HT, HT dash. And we know that the horizontal trace is a point on HP. We know that when a point is on HP, in the front view, the point will be on the XY line, and in the top view, it can be visible as in front of VP or behind VP. That means the components for a horizontal trace, there will be two components, HT dash and HT, and we know that if the point is on HP, that means for horizontal trace, your front view will be on the XY line, which means the components HT dash, considering the components HT dash and HT of the horizontal trace, HT dash will always lie on the XY line, whereas HT will be either in front of or behind the XY. Is it clear? Since horizontal trace is a point on HP, while projecting that point, its front view or HT dash will always lie on the XY line, whereas its HT will be in front of or maybe behind the XY line or behind the P. Similarly, this is the vertical trace. We know that vertical trace is a point on VP. So if VT is the vertical trace, it also will have two components, small vt and small vt dash. We know that since the vertical trace is a point on VP, its front view will be above or below HP, and in the top view, that point will be lying on the XY line. Since it is a point on VP, in the top view you can see that that point will be lying on the XY line, which means for VT, small vt will always be on the XY line, whereas VT dash will be either below or above the XY line. VT dash will be either below or above. Similarly, HT dash will be on the XY line, HT will be either in front of or behind the So I hope all of you have now understood what is a trace. Now we have to locate the traces also using trapezoidal method. It is very easy. The method is horizontal trace will always associated with the theta and vertical trace will always associated with the phi. That is the rule. Horizontal trace will always associated with the theta, whereas vertical trace will always associated with the phi. Which means, see, we have an intersection point here, right? We have obtained an intersection point here. So that point will be the horizontal trace. That point will be the horizontal trace. We know that we will have two components. For obtaining the component, draw a vertical line towards the xy line. So this will be one point and this will be another point of the projection horizontal trace. We know that for a horizontal trace, ht dash will always lie on the xy line. So this point will be ht dash and this point will be ht. So we have obtained ht and ht dash. Similarly, see, we know that vertical trace is always associated with phi. See, this is our phi, right? This is our phi. So the intersection point is here. This is the intersection point, which means this point will be our vertical trace. So vertical trace also will have two components. One is Vt and another one is Vt dash. Vt will always on the xy line and Vt dash will be above or below. So draw a vertical line. Since Vt will always on the xy line, this will be Vt and this will be Vt dash. Why? Because for the vertical trace, two components will be there, Vt and Vt dash. Vt will be always on the xy line. So from that point, draw a vertical line that will intersect the xy line, that will be our Vt. Similarly, we have obtained an intersection point here, draw a vertical line, because since it is associated with the theta, this will be horizontal trace. So when it intersects with xy, this will be our ht dash, and this will be ht, this will be our Vt, and this will be our Vt dash. And there is an important property of this this traces. See, you can extend this. This is A, this is B, and this is our ht. If you are extending this, you can see that this line will meet at this point. If you are extending this line, you can see that this line will extend at this point. And now you can see that this B, this A, ht and Vt are lying in the same straight. See, this B, A, ht and Vt are lying on the same straight line. Similarly, this Vt dash, this ht dash, this A dash and this B dash, all these 4 points are lying on the same straight. That's an important property of this trace. So, A dash, B dash, ht dash, Vt dash will always lie on the same straight line. A, B, ht, Vt will always lie on the same straight line. This is a property of traces. So I will explain again. See, the point A is given as 10/20 in front of, point B is given as 40 above 55 in front of, and the distance between the projectors A and B are given as 40. So, utilizing these three, we can locate A dash and A at a distance of 40. So, mark this dimension as 40. Mark this dimension as 40. So, at a distance of 40, you can mark this B dash. So, the dimension also is marked. Now, connect A dash with B dash, so a projection A dash B dash is obtained. That projection should be drawn with the 1H pencil in a darker way. Similarly, the projection AB also. Now, once we have the projection, the easiest method is trapezoidal method. So, how can we utilize the trapezoidal method? What is the rule behind? What is the rule in trapezoidal method? Take the distance between xy and A. Mark the distance in a perpendicular through A1, through A dash. Take the distance between xy to B, mark the distance in a perpendicular from B dash. Mark this point as A1 and name this point as B1. Connect that will be our true length A1, B1. That should be drawn with a 2H pencil in a little more darker compared to the construction lines, but it should not be darker as in the projections. Now, take this distance xy to A dash, mark here from A draw a perpendicular. Take the distance between xy to b dash, mark in a perpendicular from B and take the distance so that you will get A2 and B2. You will get another true length. These two true lengths will be equal. Now, what about the true inclination? The rule is theta will be the angle between AB and the corresponding true length. Phi will be the angle between A dash B dash and the corresponding true length. Now, what is trace? Horizontal trace will be associated with theta, vertical trace will be associated with phi. And we know that horizontal trace, two components will be there, HT and HT dash. HT dash will always lie on the xy line. In vertical trace, VT will always lie on the xy line. Now, you can measure this HT and HT dash right here. Measure VT, distance between VT and VT dash. You have to write here, and also you have to measure the true length, true inclination, theta and phi, and put it in a box. So I hope, and one more rule is there for traces. A dash, B dash, HT dash, VT dash will always lie in the same line. A, B, HT, VT will always lie in the same line. So this is the trapezoidal method. This is a simple problem in trapezoidal method. So in the next video, we will be discussing another problem in trapezoidal method. So I hope all of you have understood. And if you are like my video, please subscribe my channel.